the 17th century, it was discovered that amber was not the only material. When glass rubbed with slick or ebonite rubbed with fur were also found capable of attracting small materials. So, what I mean to say is that in earlier cases, people don't know what is electricity. What do they know? Only two things. That whenever an ember is rubbed with the wool, it can attract some particles, lightweight particles. Similarly, when glass rubbed with slick or ebonite rubbed with the fur, it can also attract small particles. So it was also found, you can see it from here. It was also found, this was also an experiment when the two silk rubbed glass rods were found brought together, they tried to repel each other. Or when silk rubbed glass rod or fur rubbed ebonite rod were brought together, they tried to attract between them. Now we know that why this happens, but this was actually beginning of the discovery of the electricity. We can show it by this diagram. Is this diagram visible to you? Can you please confirm?
Yes, sir.
Okay. It shows two glass rods. The first picture. In this case, there are two glass rods which are rubbed with the silk. When they are brought together, they try to repel each other. Similarly, the below figure, the below part of the figure shows one is the glass rubbed with silk, another is the ebonite rubbed with fur. So it showed actually charge that actually know now we know now. In the earlier days, we'd only the people only can know the attraction or the repulsion only. So in that case, we have written here like charges repel or unlike charges attract. But in those days, the term charge was not. Uh, they were not using the term charge. They were using some sort of the electricity, some sort of the fluid. Because at that time, fluid was known, but this was not known. So this is how it comes. After this, this is just actually a history of this. From this result, it was concluded that there was two types of electricity, and then this electricity was after that known as charge. So, and that material charged with the same type of electricity or which have the same type of charge will repel each other, and while those charged with the different types of electricity attract each other. So, this conclusion produced the fundamental law of charge, that is, like charge will repel and unlike charge will attract. That we have determined from the uh, figure. So this was one conclusion which results in the fundamental law of the charges. Now, around the middle century, Benjamin Franklin suggested that when a glass rubbed with slick, some kind of electric fluid, which I already told you, passed from the slick to the glass, and that gave the glass an increased amount of electric fluid. Or now we can see that is the positive charge. Or, or ebonite, when it was rubbed with the fur, some electric fluid passed from the ebonite to the fur, and this ebonite acquired a reduced amount of charge, which now we can say that it is a negative charge. Now, the modern explanation of the electrification by friction utilizes our present understanding that the atoms consists of a central nucleus surrounded by the orbital electrons, and we know that the electrons have a negative charge, and related to the nucleus, they are extremely small particles. The nucleus is largely a cluster of two types of particles, protons and neutrons, each of which has a mass approximately 1800 times that of the mass of the proton. Neutron has no charge at all, and proton has a positive charge equal in magnitude and opposite to that of the electron charge. And we can say that this nucleus is the positive charge particle. Also, we know that electrons can only occupy certain orbital rings or shells at fixed distance from the nucleus, and that each shell can contain a certain number of electrons. That we know that this electron shell has to complete this octet or duet. The outer shell named as a valence shell, and this electron that the electron that occupies this is known as a valence electrons. These valence electrons are actually most extreme for any material which can determine their electrical or chemical properties. Because the protons and the orbital electrons of an atom are equal number and have opposite charge. What I mean to say is that you will see all the atoms are neutral because the charge on the proton will be same as that of charge in the electron, because the number of protons and number of electrons is equal. You will see all all atoms will be neutral. They will not exhibit any positive or negative charge. If an atom loses an electron, it loses some negative, it exhibits a positive charge. In this case, the atom is referred to as positive ion. And all these things, I am just repeating this, you know all these things. Similarly, an atom that gains an additional electron becomes negatively charged, and it is termed as negative ion. This also you know, but I need to uh, make sure that all these things will be covered up. After that, this Benjamin Franklin, electric fluid can now be looked upon as being composed of electrons passing from one material to another material. Now we come to the another conclusion that we have left out the word this electron fluid. It has been now named as the electronic charge or electrons in general. So the material that loses electrons becomes positively charged as a result of the loss of a negative charge. Similarly, the material that gains electron becomes negatively charged because it has attained some extra negative charge. Wait a minute, I will try to admit some more people. Okay, so what is the broad conclusion? What has happened to glass or ebonite rod? So when glass was rubbed with the silic, it acquires a positive charge because it is losing some electrons to the silic. Similarly, when ebonite is rubbed with the fur, it becomes negatively charged by gaining electrons from the fur. So this is actually the conclusion, which actually starts from the name of the ember, and then it got the name of the electron and electricity. Now we have finally converted into the electronic charge. And from here we concluded that whenever an atom loses electron, it is positively charged, and it gains the electron, it is negatively charged. When glass is rubbed with the silic, it attains positive charge because it is losing some electrons to silic. Similarly, ebonite, when rubbed with the fur, becomes negatively charged because it is gaining electrons from the fur. This is the conclusion of certain slides which we have till now discussed. Now let's talk about what is voltage, what is current, and what is resistance. And I told you that I will talk about the very basics of these things. I will not tell you the exact definition that we are dealing with voltage, current, and resistance. Finally, when we first finish the basic definition, after that we will come to the actual definition of voltage, current, and resistance. For the time being, we know that when two opposite charged bodies make contact, electrons flow from the negative charged body to the positive charged body. This is a well-known fact, and this is actually a law of the nature. Whenever there are excess of anything from one part to another part, and when the excess things or excess materials find a path to go to the another path, when another place where there is a less uh, number of these things, they will go to the, so that there is a balance of these things. Same happens with the charges also. This means that when electrons move from a location with the excess of electrons to one with the deficiency of the electrons, electrons will also flow from the negative charge body to an uncharged body, or to one with a lower negative charge, which means a negative charge body which have the excess number of electrons will go to another negative charge body which have less number of electrons as that of the previous one. There also there may be a flow of electrons from one to another. Even if the other body from to which the electron flow may take place may not have any charge, may not have any number of electrons, or we can say there are electrons or protons and number of same, so net charge will be zero. There also the movement of electrons is also possible, and this movement of electrons constitute the flow of electric current. The movement of electrons is actually known as a electric current, because movement of electrons is nothing but the movement of the electric charge. Okay, you can see it from here. This is this figure visible to you?
No, sir.
It is not visible.
No,
Now
sir.
is it visible?
Yes, sir.
Okay. So it means slideshow is not visible to you. Can I do it once more? You can confirm. Is it visible?
सर थोड़ा जूम कीजिए.
Wait a minute. I will zoom it like this. Now, is it visible?
Yes, sir.
Okay. There are two actually glass rods. Rods. One is a glass rod. Another is the ebonite rod. This glass rod, as I have told you, it is this rubbed with the silic. It attains a positive charge, and we have another ebonite rod. It is rubbed with the fur. It attains a negative charge. Okay, and we have a metallic wire. We connect this metallic wire between two rods. You can see that this electron will find a path to this glass rod through this metallic wire until the number of electrons on this rod and on this rod will be equal, and this flow of electrons will constitute the electric current. That is what is meant by the electric current in general. Okay, so when this is possible, this is only possible, this electron flow is only possible when there is some path for the electrons to flow. If there is no path for the electrons to flow, there will be no electronic move, there will be no electron flow, or we can say electric current. So based on these information, the different materials are classified into two categories. One material, one category in which the electrons can flow from one rod to another rod. They are usually known as conductors because they allow the electrons to flow through them. Other materials which do not permit the electrons to flow from this one rod to another rod, they are known as insulators. They prohibit the electrons to flow through them. I hope you also know this conductors and insulators. So for the basic information, you should know this. Now, because we know that what is the resist, simply resistance is nothing but the opposition to the electronic flow. The more the resistance of a material, the more it will tend towards the insulators, or we can say the insulators have more resistance to the flow of current as compared to the conductors. So basically, the materials which are conductors, they will allow the flow of the current, they will have the lower resistance to the flow of the current. We can say that the conductors offer lower resistance to the flow of the electric current. Conductors obviously have much lower resistance, as I have told you. Electric current is usually measured in amperes, whose symbol is ampere, and resistance is usually measured in ohms, whose symbol is the ohm, that is the Greek letter omega. Now, one more thing, that the ability of the two oppositely charged bodies to produce a flow of electricity between them may be thought of a potential or a production of the electric current. So, what I told you, we have slightly, I cannot say exactly, we have defined the current and resistance, but in layman's language, we can say current is the flow of the electron, and resistance is the opposition to the flow of these electrons. Now, we'll try to define what is the voltage. So, from this sentence, you can see that I have told you that this is actually the ability of the two charged bodies which can produce the electricity or which can produce the flow of these electrons. Because this potential will describe how much electrons will flow through any particular path unit time. So it can be thought of a potential or potential for production of the electric current. If a positively charged body is said to have a positive potential, usually it's not a, it is a general term. For example, we have two rods here. This is exactly positive charged, this positive charged rod, this is negative charged rod. We can sign this positive charged rod as positive and this negative charged rod as negative. This is true, but sometimes this may also be true. For example, if this has negative charge, this is also negative charge but less negative charge. Next negative charge also be nomenclated as positive, and negative charge with more negative charge in magnitude will be considered to be negative, will be put a negative sign in front of this. So I want you to be clear in that it is not only the positive or negative charge, it is actually higher amount of negative charge, lower amount of negative charge. Higher amount of negative charge will be considered to be negative. Lower amount of negative charge will be considered to be positive. Similarly, higher amount of positive charge will be considered to be positive. Lower amount of positive charge will be considered to be negative. Similarly, and for positive and negative, it is very simple. Positive is considered to be positive, and negative is considered to be negative. This is what I have written over here. A positive charge body is said to have a positive potential, and thus and plus sign is used to identify the potential on all the diagrams. Similarly, a negative charge body is described as a negative potential, and a minus sign is used for it is identification. Now, when there are two oppositely charged bodies, they are said to have a potential difference between them. You can see it from this figure. It has its own potential. It has its own potential. There may be some potential difference, and we're always interested with the potential difference rather than with the potential, because it is potential difference they, that makes this current to flow, not the potential. Because if there is potential difference between these two, only then the current will flow between these two. If there is not any potential difference, even if there is some potential, the current will not flow. As I told earlier, for example, the electrons, the number of electrons here are same as the number of electrons over here, and we say that there are potential. It has negative, here it has negative, but potential difference will be zero. There will be no current flow through this. So we'll be always interested in the potential difference rather than the potential only. So it is also possible for a potential difference to exist between two similarly charged bodies if one charge is higher potential than the other. I have just described it. If two positively charged bodies are there, one has a more positive charge, another has a negative positive, less positive charge. We know there's some potential difference. Similarly, if you have a negative body charge which have more negative charge as compared to the other body which has less negative charge, there also a potential difference may exist apart from the two bodies which have positive and negative charge. Now from here, potential difference is measured in volts. This is we are talking about in its unit, and its symbol is V. And the term voltage is commonly applied for the potential difference. We usually say we are interested in the potential difference, but we always represent it, or we always talk about the voltage, not the potential difference. Another more descriptive term for the potential difference is electromotive force, EMF. This is another name of the same thing, that is potential difference, voltage, or EMF. They are almost a similar thing. So electromotive force, voltage, or potential difference, we can say it is an electric pressure that tends to cause electric current to flow when a suitable conducting path is provided. So in general, it is a force that is used to provide the current through the conducting path when it is provided. So lastly, we can show an analogy between electrical potential and some sort of a tank. We have this figure. I think this is not so visible. Is it visible to you, this figure? Anyone can respond? Is this visible to you?
Yes, sir.
Okay, thank you. So you can see from here, we have our two water tanks. They're connected to each other through two pipes. The upper pipe has a larger diameter, the lower pipe has a smaller diameter. So from these two tanks, you can see there is a water level difference. Isn't it? When there is a water level difference, you can see that water will flow from a water tank whose water level is higher to the tank whose water level is lower. Also, you can see that the water that flows through the smaller pipe will be, the speed of that will be less as compared to the water through the pipe with the larger diameter. So in that case, same analogy we can use for the two bodies which have the different potential. We can say which have some potential difference. So the water tank A has this height. You can say charge body A has this much of charge. You can see the more number of negative means more number of electron charges. Less number of negative means less number of electron charge. So here you can see the current will flow from the negative charge, we have more number of electrons, to the other one which less number of electrons. But here also there are two paths. Here also you can see that same analogy, the electrons will follow more, will flow more towards the pipe which has more area, or we can say which has more cross sectional area or diameter as compared to the pipe, or we can say conducting material which has less area. So we can conclude from here, from figure this, tank A has a larger quantity of liquid than tank B, so that at the level of the connecting pipes there is a pressure causing water to flow from tank A to tank B. Similarly, in the figure 1.4b, body A has a larger quantity of electrons than a body B. Consequently, there is an electrical pressure, electromotive force, which we have already discussed, causing the current to flow along the conductors from A to B. That is very evident from here, because it will allow the current to flow from A to B. That is the electron current, the actual current. So the larger diameter water pipe passes a greater water current than a smaller diameter pipe, and the conductor with a large cross-sectional area passes a greater electrical current than a conductor with a small cross-sectional area. Thus, larger diameter conductor offers less resistance to the current flow than the small diameter conductor. Actually, this also you might be knowing, because you know that resistance which is proportional to, now which is equal to rho L by A, where rho is the resistivity of the resistance, L is the length of the that material, L is the cross-sectional area through which this current flows. So this resistance from that point of view can also be viewed that resistance is inversely proportional to the cross-sectional area of the conductor. In that case, you can see resistance has decreased. So what is the final conclusion? Voltage, EMF potential difference, is an electrical pressure that produces the flow of current. This is the movement of electron through a conductor. Resistance is the opposition to this current flow. This is the final conclusion from this, which we have already discussed. So I think I will stop over here, because this is the first class. I don't want it to be more longer than this. I hope you have. I don't know whether you enjoy it, but I want to stop it here. So I will first uh, like some questions from you. If there is any question from anyone, I will first take question, and in the meantime, I will take your attendance. Anyone have any question? Please tell me. Basit, any question from your side? Basit, is anyone listening to me?
Yes, sir.
Uh, have any question?
Sir.
आपका नाम क्या है? इरफान.
Yes, sir. Yes, sir.
Okay. Where are others? Abdul Basit, are you there? I don't know whether they are there or not. इरफान,
Yes, sir. Yes, sir.
आप मुझे बताओ, आप किस डिपार्टमेंट से हो?
Sir, mechanical department से sir.
आप सब मैकेनिकल डिपार्टमेंट से हो?
नो सर, सिविल से।
Sir,
मुजम्मिल,
civil.
Yes, sir.
आपको आ रही है
Mechanical.
आवाज मेरी?
Yes, sir. Muzammil mechanical.
आप भी मैकेनिकल से हो?
Yes, sir.
ठीक है. मुझे बता, इसमें जो टोटल है इसमें बहुत सारे हैं, लेकिन आज मैंने देखा only 16 have joined the Google Meet classes. So
सर जो
can you
स्लाइड
please?
नंबर 18 आपने बोला ना सर,
हाँ हाँ हाँ, वही तो क्वेश्चन
सर
में.
वो एक बार आप ओपन कीजिए।
स्लाइड नंबर 18, दिस वन. अच्छा, अभी आपको दिखना, एक मिनट, मैं इसको पहले शेयर करता हूँ. लेट मी फर्स्ट फिनिश द अटेंडेंस. जस्ट अ
ओके
मिनट.
सर।
It is but this Dar Irfan. फैसल निसार, फैसल अहमद, हारिस रशीद, okay. Now I will show you again slide number 18,
यस सर,
जिसमें मैंने एनालॉजी दिखाई थी, वही
यस सर,
ये वाली आपको दिख रहा है?
यस सर।
हाँ
सर जो
बताओ।
आपने जो बोला ना, जो ये चार्ज ट्रांसफर होता है हाई पोटेंशियल टू लो
बिल्कुल
पोटेंशियल, सर इसमें जो वो होता है, जो अगर इलेक्ट्रॉन होगा या प्रोटॉन होगा, वो
ठीक,
हाई पोटेंशियल से लोअर पोटेंशियल ट्रांसफर होगा।
बिल्कुल
लेकिन वो हमने है ना, जो लाइक चार्ज रिपल करते हैं, अनलाइक चार्ज अट्रैक्ट
ठीक।
करते हैं, वो इसमें अप्लाई नहीं होता है।
वो इसमें भी होता है, जैसे मैंने आपको कहा कि हाउ मेनी चार्ज पार्टिकल बॉडी ए, आप मान लीजिए इसमें 100 नेगेटिव पार्टिकल चार्जेस हैं,
जी
है ना?
सर।
हम
हाँ
इसको उसी के हिसाब से देखेंगे। और चार्ज बॉडी बी है, लेट अस से इसमें 10 चार्ज ये इलेक्ट्रॉन्स हैं, ठीक है?
जी सर।
अब फोर्स ऑफ रिपल्सन किस में ज्यादा होगा, बॉडी
जिसमें
ए में आपस में कि बॉडी बी में?
बॉडी ए में।
बॉडी ए में, है ना? वो क्या
हाँ
करेंगे,
सर।
उन इलेक्ट्रॉन्स को बाहर फेंकेंगे टुवर्ड्स द बॉडी बी।
हाँ यस सर।
तो वो कहाँ जाएंगे, यहाँ पर भी उनका रिपल्सन होगा, लेकिन रिपल्सन क्या होगा, यहाँ से ज्यादा रिपल्सन होगा, वहां कम होगा। वो कब तक बराबर आएगा, जब तक यहाँ के चार्जेस वहां के चार्जेस बराबर नहीं आएंगे, वो आपस में रिपल्सन बराबर करेंगे एंड द नेट फ्लो ऑफ द करंट विल स्टॉप। ये उसको ऐसे भी बोल सकते हैं, ठीक है ना?
ओके सर, ओके सर।
इज एनीवन, किसी और को कोई क्वेश्चन, प्लीज लेट मी नो।
सर बॉडी ए में सर डेंसिटी कोई अफेक्ट करती होगी सर इसमें?
कौन सी डेंसिटी?
सर डेंसिटी ऑफ चार्जेस सर।
होगी ना, डेंसिटी ऑफ चार्ज तो होगी ना इफेक्ट।
यस सर।
डेंसिटी ऑफ चार्ज विल ऑटोमेटिकली विल रिड्यूस, वी कैन से द पोटेंशियल विल रिड्यूस। बैटरी में फिर वही होता है ना, उसका जो वोल्टेज है वो कम हो जाता है। वो क्यों होता है? बिकॉज देयर इज द इवन डिस्ट्रीब्यूशन ऑफ द चार्ज, आफ्टर दैट पोटेंशियल डिफरेंस कम हो जाता है, जिसको हम बोलते हैं बैटरी डिस्चार्ज हो गई।
यस सर।
आर यू गेटिंग माय पॉइंट?
ओके सर। यस सर।
एनी अदर वन? अब्दुल बासित, आप बताओ, आपको कोई क्वेश्चन? हाँ, बिफोर गोइंग इनटू दिस आई वुड लाइक टू टेल यू द मार्क्स डिस्ट्रीब्यूशन ऑफ ऑल दिस। मैंने जो मैं रखता हूँ यूजुअली इसका, इसमें मार्क्स 50 तो होंगे, 50 एंड 30 विल बी फॉर एंड टर्म एंड मिड टर्म रेस्पेक्टिवली। 20 विल बी, 20 का जो ब्रेकअप होता है दैट इज यूजुअली, उसका तो डिफाइन मैं नहीं करता हूँ पर्टिकुलर मार्क्स कितने होते हैं, बट आई विल टेल यू कि मैं मार्क्स को डिस्ट्रीब्यूट किस किस में करता हूँ। दिस मार्क्स विल बी डिस्ट्रीब्यूटेड अटेंडेंस प्लस क्लास टेस्ट प्लस दिस असाइनमेंट, ठीक है? सो प्लीज ट्राई टू नोट दीज थिंग्स।
ओके सर।
एंड मुझे याद नहीं है मैं क्यों नहीं रखता हूँ इसको, कि अटेंडेंस के कितने मार्क्स हैं, क्लास टेस्ट के कितने मार्क्स हैं, असाइनमेंट के कितने मार्क्स हैं। कभी कभी क्या हो जाता है कि फ्रॉम द लास्ट ईयर मेरा एक्सपीरियंस है कि अटेंडेंस फेयरली नहीं हो पाती है, तो उसके मैं कभी कम रखता हूँ, या कभी क्लास टेस्ट मैंने नहीं लिया, नहीं ले पाया, असाइनमेंट्स कम हो गए। सो जितने हिसाब से मैं ये करूंगा, तो उसी के हिसाब से मैं आपको बता दूंगा लास्ट में कि किसके मैंने कितने मार्क्स रखे हुए हैं। बट यू शुड नॉट बी, आप इसका में गड़बड़ाए नहीं, इसमें जो मार्किंग होगी दैट विल बी इंशाल्लाह फेयर, ठीक है?
ओके सर।
ओके, ठीक है। और अगर
हाँ
कोई क्वेश्चन भी होगा ऐसे, यू कैन मीट मी पर्सनली इन द डिपार्टमेंट, क्योंकि आप तो आएंगे ही ना इसमें
यस सर।
वीकडेज में, तो आप मुझे डिपार्टमेंट में पर्सनली मिल भी सकते हैं। कोई क्वेश्चन होगा, कोई कुछ भी होगा, क्योंकि ये सारी चीजें हैं, जैसे आपने कहा कि मैं मैकेनिकल में हूँ, आपने तो ये फिजिक्स में भी पढ़ा होगा, आपने तो ये बेसिक इलेक्ट्रिकल इंजीनियरिंग में पढ़ा होगा। तो मैंने आपको पहले ही कहा कि मैं वेरी बेसिक से पढ़ाऊंगा आपको, क्योंकि बहुत सारे बच्चे ऐसे हैं जो कि आर्ट्स के बैकग्राउंड से आएंगे ओपन इलेक्टिव में, या किसी और बैकग्राउंड से आ सकते हैं अपार्ट फ्रॉम साइंस बैकग्राउंड एंड दिस इंजीनियरिंग बैकग्राउंड। तो उसी के हिसाब से मैंने इसको किया हुआ है। सो जिस जैसे जैसे हम आगे इंशाल्लाह बढ़ेंगे, यू विल फील मोर इंटरेस्ट इन दिस। ओके, थैंक यू फॉर बीइंग पेशेंट। और
ओके
बाकी
सर।
स्टूडेंट्स को भी बताइएगा कि जो जो नेक्स्ट क्लास होगी वो अपने टाइम पे होगी, क्योंकि ये अचानक हो गया था, मुझे भी मतलब अपने जो मेरा अपॉइंटमेंट था वो मैं कैंसिल नहीं कर पाया। तो नेक्स्ट टाइम से अपने टाइम पे होगा इंशाल्लाह। ठीक है,
ओके
बाकी
सर।
स्टूडेंट्स को बोलना कि ज्वाइन करना गूगल क्लास भी और ये भी। आई विल शेयर दीज स्लाइड्स इन द गूगल क्लासरूम, यू कैन, इफ देयर इज एनी प्रॉब्लम यू कैन चेक इट विद दैट। ओके,
थैंक यू सर।
थैंक यू वेरी मच।
वालेकुम सर।
वालेकुम सलाम।
सर क्लासेस अब से सर ये सैटरडे संडे होंगे क्लासेस?
क्लासेस होगी सैटरडे है ना खाली?
सैटरडे संडे?
आपने टाइम टेबल नहीं देखा?
हाँ सर देखा।
उसमें क्या लिखा है?
सर पहले बोला था जुबैर सर ने शायद ओपन इलेक्टिव के क्लासेस सैटरडे और संडे होंगे।
एक्चुअली ये इस पे है सैटरडे या संडे, या कभी कभी अगर एक्स्ट्रा क्लास होगा तो सैटरडे
यस
संडे
सर।
ही होगा बस। क्योंकि कल हमारी एक्चुअल में क्लास कब थी? कल। तो मैं
यस
नहीं ले
यस।
पाया, मैंने आज लिया, इसी का मतलब होता है सैटरडे संडे। सो
सर
यू डोंट
गूगल
वरी
मीट पे ही
अबाउट इट।
होगा कि जूम पे क्लास होंगे कभी?
जूम और गूगल मीट में क्या डिफरेंस है?
सर उससे थोड़ा
उसमें
उससे
आपको कोई दिक्कत हो रही है गूगल मीट से?
नहीं सर, मैं सोचा अगर आप जूम पे ले सकते हो तो वो भी ठीक है।
दरअसल इसलिए मैंने गूगल मीट पे लिया है कि अब मुझे वो कंफर्म है या नहीं है कि जो जूम
जो है सर
हमने
उन्होंने सर
सुना
अभी
था।
किया हुआ है सर। जी सर।
हाँ हाँ,
सर कुछ स्टूडेंट्स ऐसे जिन्होंने सर अभी ये गूगल मीट जो है सर ये मतलब सर इंस्टॉल नहीं किया हुआ है सर।
मेरी बात
उनको
सुनो
एक बार
पहले कंप्लीटली। मैंने
कंफर्म।
गूगल मीट क्यों, मेरी बात सुनिए पहले, गूगल मीट मैंने क्यों उसमें प्रेफर किया? एक तो ये है कि जूम में सुनने में आया था कि उसके कुछ सिक्योरिटी इशू है, हो गया वो।
सर क्वालिटी भी अच्छी है उससे।
तो दूसरा ये कि इसमें गूगल मीट है ना, इसमें एप्लीकेशन की जरूरत नहीं पड़ती है, यू जस्ट हैव टू, इसमें आपको क्या बोलते हैं, डायरेक्टली आप क्लिक आप डायरेक्टली आ जाते हैं इसमें, इसमें एप्लीकेशन की जरूरत नहीं पड़ती है। इसलिए मैंने ये किया, और आपको कोई अकाउंट वैकाउंट बनाने की जरूरत भी नहीं पड़ती है।
ओके सर ठीक है।
आर यू गेटिंग माय पॉइंट? इट इज वेरी इजी एंड कन्वीनियंट। इसीलिए मैंने ये गूगल मीट रखा, क्योंकि हमने देखा ना, जूम भी देखा, बाकी चीजें भी देखी।
यस सर।
सो हमने ये किया हुआ है पहले।